And now, apart from knowing how to represent the equation of a line in a vector form, okay, we also need to know how to represent it in a Cartesian form. So we say the Cartesian equation of a line. Now, if you recall, what does Cartesian mean? Cartesian means the equation of the line is just in terms of x, y, z. All right, so we don't want to see a t. Okay, so how do we get rid of the t? Now, and how do we bring in the x, y, z? Okay, so a vector r, right? Instead of writing vector r, now I'm going to write vector r as column vector x, y, z. Makes sense because usually, that's how we label our vector. All right, so x, y, z, where each of them is equating to the x, y, z component of the equation. So when I plug it in, if I compare the x component, y component, z component, I'm going to have three equations. Now remember, I don't want the t. So naturally, I want to make t the subject in each of these equations. And I'm going to equate the three of them together so that the t will disappear. And this is what I'm going to get. X minus a1 over u1 is the same as y minus a2 over u2, z minus a3 over u3. All right? And this is known as the Cartesian equation of a line. All right, you must be able to identify or at least know what does this u1, u2, u3 mean and a1, a2, a3 mean. All right, when given a Cartesian equation. So recall, if you are given a Cartesian equation of this form, so a1, a2, a3 represents a point, a fixed point on the line, whereas the u1, u2, u3 is the vector which the line is parallel to. Okay, so this is something very important. Okay, so now you are asked to find the Cartesian equation of a line through the point, these two. Okay, now remember to find the equation, whether is it Cartesian or is it vector equation, you need to know a vector which is parallel to the line. You also need to know a fixed point on the line. Of course, we have 2 points now, so no issue with the fixed point. But what is the direction of the line? Now, it passes these 2 points, so to find the vector that is parallel to the line, I just need to do this. All right, take these 2 vectors, subtract each other, and you get the direction, a vector that's parallel to the line. So if you're not confident to immediately change to the Cartesian form, what you can do is you can actually write it in a vector form first, and then you convert it into the Cartesian form. All right, so how do you do it? Remember, you replace your r by x, y, z, right? And then now you make it into 3 equations, make lambda the subject, and then convert it into the Cartesian equation. Now, but as I mentioned, if you are very confident, you don't have to do all these steps. Okay, if you recognize immediately, it's always x minus the I component of the fixed point, then followed by y minus the j component of the fixed point, then z minus the k component of the fixed point over the I component of the vector that is parallel to the line, and then the j component, then the k component. You can do it immediately. All right, but if you want to be safe, you can do all this working, no issues. All right. Now, what if, what if one of these vector, okay, u1 or u2 or u3 is 0. All right, then it doesn't make sense that we use the general form. Okay, because if either this u1, u2 or u3 is 0, then it becomes undefined. So just to take note, if any one of them is actually equals to 0, this is the expression that you should be using. All right. And so an example is if you have a Cartesian equation of a line of this form, you notice u3 is 0. So instead of writing z minus 3 over 0, you should just write z equals to 3. Alright, so now you have learned two forms, okay, for the equation of line, a vector form and a Cartesian form. You should be able to convert from one form to another quickly. Alright, so suppose you are given the Cartesian form, you should be able to convert it into the vector equation. And similarly, if you are given this form, okay, this is a little bit more tricky, not so straightforward as A. Okay, so just try to convert this into a vector equation. Alright, you can pause the video now, try it, then after that, I'll review the answers. Okay, so now if you have tried B, hopefully you managed to find the equation of the line, which is this. If not, let's look at how we can do it step by step. Alright, first we will define x to be equals to lambda, and because x is lambda, so it will give us z equals to 2 plus half lambda. So how do you get that? Basically, based on the equation above, okay, sorry about that. So given x is equals to 2z minus 4, right? So if now you have let x be lambda, so you will have 2z minus 4. And now you make z the subject, so you get lambda plus 4 over 2, which gives you 2 plus lambda over 2. Alright, so this is z, and this is, and then you are already told that y is equals to 3. Okay, so now if you put it in the column vector form x, y, z, which usually represents r, right? So x, y, z. So x is lambda, y is 3, and then z is this 2 plus lambda over 2. Now, pull out your lambda, set it aside. Those terms that have lambda, put it in one column vector. Those without lambda in another column vector. Now you can pull out your lambda and you will get the vector equation of a line. Now, as I mentioned, this is a systematic way of doing things. So if you have a faster way, because you managed to do it in your mind, yeah, sure, go ahead. Because this is not a show question, so you don't have to do all this working. But if this question is a show question, then all this working is required. All right, and remember you need to write alpha is real. Okay, now actually this is something important to know, because next time when we reach vector 6, there will be a lot of contextual question. So you need to know the vector equation of the x-axis, the y-axis, and the z-axis. And they are simply just alpha, 1, 0, 0, beta, and then gamma. Okay, or mu, sorry, of 0, 0, 1. All right, in case you don't know why, actually go and think about it again. We mentioned about the vector equation of a line consists of a fixed point on the line, as well plus the position vector of a fixed point on the line plus lambda times of the direction of a vector that is parallel to the line. In this case, 1, 0, 0 is parallel to the x-axis. All right, so this one for sure, we know this is the line that is parallel to the x-axis. Now, how come there's no addition of a position vector on the line? Now, if you remember, the origin is actually on the x-axis. So actually, the fixed point that I chose is the origin. So it's actually plus the 0 vector, which is as good as not writing it. And that's why it's just simply r equals to alpha of 100. Okay, and then the same works for the equation of the line of a y-axis as well as z-axis. So I strongly encourage you to remember this, because sometimes it's difficult for us to recall or derive on the spot. Okay, so this is the end for equation of a line.